All right, next question, next page. So we've got this block, it's pushed against a wall, and that makes things a little bit weird when we draw a free body diagram. We've got the applied force, we've got the normal force from the wall pushing backwards. Be careful, normal forces don't just have to go upwards, they go perpendicular to the surface that we're resting against. In this case, we're resting against a wall. So we have the weight, and we have the force that's supporting the block, and the only thing that could be doing that is static friction, which actually is the answer to number 9. Now, we want to get the value of the static friction acting on the block. Well, nothing's moving, so let's use statics. In the y direction, I know Fs equals W, and I also know that in the x direction, Fa equals the normal force. So I know that the static friction must be equal to the weight from the equation. So I have m 0.5 times 9.8, the acceleration due to gravity. And so I'm going to end up getting 4.9. If you use 9.81, you would get B, but in either case, 4.905 newtons. Now, if the coefficient of static friction between the wall and the block is 0.2, we want to get the force necessary to keep the block from slipping. So let me actually just take my equations and make sure that I've got them available to me right here. And we'll go ahead and plug in a couple of numbers. So first of all, I know that the friction force is 4.9. And what I want to do is basically get the applied force from that if I can. So I know that friction is mu times n. So if I have the friction is 4.9 and I know that mu is 0.2, then n is something I can solve for. And I'm going to actually end up getting 24.5 newtons for the normal force. But what I realize is that the normal force, in fact, equals the applied force. And so that's how I'm getting E as my answer. So that's it for the next page, and we'll continue in the next video.